There we go. Hey Hacksters, what's up? We were just here with an overview of the new ESP32-Pico-D4 dev chip from Espressif Systems, and it's on this board that's called the, what is it again? ESP32 core board? I always forget. Oh yeah, ESP32 Pico core board, V3. And yeah, we just did a video showing you some places you can get a hold of this or get more information about it. It's super cool. It's kind of a new sibling to the ESP32 that we know and love, and I just went to a workshop on it yesterday. Yeah, cool. So this workshop that we're about to do was put together by the people at Mongoose OS, and it uses Mongoose because, yeah. So Mongoose is an OS for commercial connected products, but you can use it as a maker too. It's really functional. Basically, you can use it from your command line or from your browser, and it does, if you've worked with the BeagleBone, it's a little bit similar to that in that you know, you're working with it in your browser, but also it's not hosted on the board. It's instead something that, okay, I'm gonna get this backwards. Okay, yeah, you install it on your computer, and then from the CLI, the command line, you run this command that boots it in your browser. And then you use that to program. And Mongoose allows you to do over-the-air updating, so you don't have to go grab your device and plug it in. If it's already connected to Wi-Fi, you can just flash something new from your browser, which is pretty cool. There's also a bunch of projects already using this on Hackster, so if you look at mongoose-os, or just search for Mongoose, I mean, you're not going to get much namespace collision there, because, yeah, I don't know. We need more, like, common mongoose as pets. Why is that not a thing? Anyway, yeah, lots of resources there. It's also part of our Hackster Apps suite. If you're not aware of this, you should go to Hackster.io/apps. It's a bunch of browser-based tools that make it really easy to spin up new projects. So if you're a new maker, there's all kinds of stuff from like making PCBs with Upverter. I'm actually on my way finally to making my first PCB. It's been so long. But Upverter is a great tool for collaboratively creating PCBs. You've also got Mongoose, which is your browser-based flashing stuff onto boards thing, and it's a central sort of management system, which is great. You've also got Circuito, which is great for you know, you basically drag and drop what stuff you want to hook up together with Arduino, and then like what kind of wireless connectivity you want to have, what kind of outputs, etc. And then you just hit the button, and it creates code and a breadboard drawing and schematic for you, so you can just sort of build it according to that, which is great if you're a starter. And then also Porter, which is for firmware development and testing and refining and prototyping. So check those out. On to, oh yeah, also in terms of Mongoose, there is a cool GitHub repo that's got some projects in it. But yeah, plenty of stuff on Hackster too. So this workshop is also going to use MQTT, which is a machine-to-machine IoT connectivity protocol. It was designed as an extremely lightweight publish/subscribe messaging transport. So you know, there are other ones like Sigfox and whatnot that are like ways of sending messages between devices. And this doesn't have a network associated with it, but it's useful for connections with remote locations where a small code footprint is required, and network bandwidth may be at a premium. So you know, you're not sending a lot of data back and forth, which is great for power, for bandwidth, for speed, for low packet loss and things like that. Pretty cool. Yeah, it's been used over dial-up connections. No way. Anyway, it's great for like IoT and home automation and stuff. Let's close some of those. Okay, so here's the workshop that I went to yesterday. It was hosted at the AWS pop-up loft in San Francisco, which is a cool space where you can go and work for free. That's all my plugs for today. And they gave us these boards, these dev kits, which this is the board here, this pretty matte black one. And then the red one is a dev kit created by a member of the Espressif team, I think, specifically for this workshop. And they're probably not going to make that many of them, but it's wonderful. And it's got 5 NeoPixels, WS2812s, and 4 programmable buttons. And that's what we're going to be using. But they also tell you what I2C connections the sensors are on and what GPIO pins, that's the general purpose input-output pins that you hook stuff up to, like digital, 3 or analog 4 or whatever. Those are all labeled on here, so you're not dependent on having one of these boards. You could simply plug in an LED or a button or whatever on the pins that we're going to be using. So don't worry, you may not be able to get one of these boards, but you'll totally be able to do this workshop. So the workshop is at mongoose-os.com/AWS-Pico, and I've linked to it next to this video, okay? So there was a bunch of setup stuff that I won't subject you to. There are a couple of notes with that, though. There's definitely lots of excellent resources on this. This is just a sort of table of contents. You do the cloud-side setup, which is setting up the AWS CLI, which stands for Command Line Interface. This is where I got hung up for about half an hour. And at the end of the workshop, the power actually went out for a while, so I ended up having to finish this at home, but it worked pretty well. So this is a cross-platform project. You don't have to have any particular OS to do it. I'm using Mac OS and a fairly recent version of the OS, which means that I ran into this specific weird issue with setting up the AWS command line utility. They link you to the general command line interface setup page, which is pretty minimal, but it does link you to the GitHub project. And that was where I had to go to find out about this bug. When you're setting up the AWS CLI command line interface in your terminal on your computer, if you are running a new version of Mac OS X, you might get an error that will send you running around in circles forever. And you just have to use this extra flag, which is ignore installed 6. Yeah. So that's my little quibble there. So you install the AWS command line utility. And to make sure that that's working, you run AWS IoT list-things. Let's have a look at how that looks. And if it goes well, yep. So we can see that I've already set this thing up once, and you get this little thing. Obviously, most people are not going to have already done this before, so you're going to get, it also shows an example of what it would look like otherwise. Basically, you just don't want an error. Then you set up the device and install the Mongoose tool on your computer. MOS, Mongoose OS goes on your computer. And the way that you start it is shown in the installation guide. It is this command right here. So I'm going to show you what that looks like. And hopefully it'll open it in the same browser window, so we'll have no problems. Let's show you iTerm. Yep. Doop, doop, doop. And yep, okay, we've got it in the same browser window. That's good. You might have seen this booting up behind my terminal screen. So this is running on port 127, or address 127.0.1, port 1992. I don't know if that has special significance to somebody, but then /files. And I'm gonna set this device up again because I want it to connect to our office Wi-Fi and not my house. So I have this driver that allows it to detect USB to UART. Select. I've already flashed the firmware, so I don't need to do that again, and I'm going to configure the Wi-Fi. We have a dedicated device network here at Hackster because we do a lot of things like this. So and in the bottom of the window, you can kind of see some log messages scrolling there. Oh, what if I make the window smaller so it all fits? Fancy that. Oh, it doesn't change anything. Woohoo! Okay, cool, here we go. We've got our device file manager here, and I'm going to try making this window a little smaller so you can see better. Wrong window. Whoop. There we go. Cool. What have we got? So we should have files on this device. Oh, refresh file list. There we go. Whew. and it's still got my previous file on here from the tutorial, so let's just remove that. This is what it looks like when it comes to you first. So it's print hi when you first flash it. And all your feedback is going to go in this bottom left corner, the device logs window. So soon we should get a little hi in there. We'll see. Okay, fine. You're just going to straight up refresh everything. That's fine. Okay, so it also shows the detailed tutorials thingy. What are we doing now? Right, so most of the editing that we're going to be doing is going to be in the init.js file, and that's how you know that you're mostly working in JavaScript. I mean, if it wasn't already obvious, init.js is obviously JavaScript. Oh yeah, you have to configure your device to use AWS in the region that your account is associated with. So let's pull this over here, and that's in the device config area. And then over here is where you set it up. And I'm not going to go through that process with you because it might show some sensitive things. But it sets up this certificate and this key on your device so that it's able to identify itself, and you know that there's no one else is going to be able to mess around with it, which is cool. It allows it to authenticate to your AWS account. And in the AWS Management Console, this is what you see when you log into AWS as a developer. AWS IoT is right over here, or if you've seen it recently, it's going to be up in the recently visited services area. And you can see on here that I had a bunch of successful connections yesterday, all using MQTT. And it was a number of different types of interactions, and some of them were inbound and some were outbound. We will see what that looks like later on in this testing area. But let's get started. We provisioned it to AWS IoT. That happened. It was great. So now we have an IoT button tutorial, and this is the first real actually interacting with the internet IoT part of the tutorial. So we're gonna grab this code and throw it in this init.js file. I can print or delete the printed hi if I wanted, but I don't because I think it's cute. Then you're loading a couple of JavaScript files that teach it how to interact with the GPIO pins and the MQTT protocol. You are going to be subscribing and publishing to a topic on AWS, and AWS is going to be having the same thing on the other end. You tell it to subscribe to a particular MQTT topic. So they're both going to be talking on the same channel. And then your pin 36 corresponds to user button 1 on here. So that's going to be this top button here. GPIO set button handler, when the button is pushed, it's telling the button 1 that it should be initially set up as an input with a pull-up, which means that it has an internal resistor that connects it to power when it's not doing anything, which means that you don't have it floating somewhere in the middle. And when you push the button, it's going to be connected to ground. So let message equals JSON stringify foobar. Yeah, and you're telling it where to publish to. The message that you're sending is going to be as a string, and then you publish into the little feedback console that I mentioned. Oh, for you it's down here, isn't it? Yeah, right there. It's gonna print stuff to that console. All right, let's save this and reboot, which is what you need to do in order to make sure that it's actually gonna do that stuff. It's connecting, new heap free. I don't know what that means. But we have new heaps, that's great. So now on the AWS IoT side, we're going to subscribe to MOS/topic1. So MOS/topic1. All right, and then we get this interface. This actually didn't work for me the first time I did it. I had to re-upload the code and try again, but let's see. Oh, yes, there we go. Gorgeous. Yeah, see, you can just do it like, and we instantly get this updating message. You can see that each time I push the button, it logs a new one at the top of the list. And that's going straight into the AWS IoT console because they're both talking on this MQTT communication channel. Cool. I'm so glad it worked on the first time this time. So that's tutorial number 2. Then we have tutorial 3, send light sensor data. So again, this guy has a light sensor on I2C. And it's on the dev board itself. So where is that? It's IC2 on here, and it's at 0x29, and it's a BH1730 light sensor. Cool. Let's grab this code. And again, we're pasting into the init.js file. Save and reboot. Okay, so this guy, oh, I'm gonna go pause this actually for a second. It's gonna start publishing like immediately. Yeah, see, note that it says published 1, published 1, published 1. And each of those is updating the AWS console with the reading. And it's the light sensor, so I actually didn't play around with this last time. I can't believe I didn't do that. So let's see. Lux is 1301, 9082, 963. If I put my finger onto it, it becomes about 100. Take my finger off, it goes back up to about 1,000. That's really cool. So let's have a look at this code then. This time we are importing another JS file, MQTT for communication, API timer.js. So that means that's because it's doing this once per second. And then BH1730, which is the sensor that we've got. So then again, we're talking on MOS topic 1. We create an object for the sensor. We set a timer 1,000 milliseconds, which is once per second. Then you, again, stringify the readout from the sensor. Then publish it to the topic, and then print published into the console. Oh, that OK probably means like a value of 1 or 0 based on whether or not it's actually OK. Cool. So presumably if something went wrong with publishing, like maybe if we were not connected to the internet or something, I'm not sure, but that would show published : 0, meaning that it's not published. So you got a little bit of debugging feedback. It's really cool like going through this a second time. So yeah, that's the Lux sensor. Next up, send temperature sensor data. Oh yeah, and on that one, yeah, the 0x29 should be the same I2C address that's printed on here, and that's true. Cool. This is just a really great example of a tutorial, by the way. I'm going to turn this into a Hackster tutorial linking to the original one, but also including the little notes and stuff that I've done along the way. But in general, I think this is just like a really well-documented one, and you should totally take your cues from this one. We also have a couple of really cool examples, a couple of projects that you'll see when you try to publish your own project about how to create a really well-done tutorial, and I want to just give them some props for this because it's got screenshots, it's got GIFs, in some places it's got the code and it tells you what it does. All right, so next up, temperature sensor data. Let's throw this in here. I haven't actually seen it print high yet. Maybe I can scroll up while it's doing its thing. Oh, it's probably just somewhere buried in here. Oh, here it is. Cool. Oh, and then it does all the initialization. Cool. It's before that heap message. Oh my god, it's already publishing. In the AWS IoT console, you can also pause watching the stream. So that's really useful. Okay, what are we doing? We're loading MQTT, loading the timer, BH1730, which is the other sensor here. And, ooh, an Arduino library, it looks like. BME280. Huh. Oh, that's the sensor, is the BME280. B81730. Oh, is the other one, is the light sensor. Oh, right, we're publishing both this time. Okay, cool. Because as you'll see, you do the topic thing, you create an object for the light sensor, you create an object for the temperature and humidity sensor, which apparently has its own Arduino library that you're just importing there. And then you begin that sensor as well. And then you do your 1 per second timer, and then you print these guys. Lux, your light sensor, temperature, humidity, and pressure. I clicked on the wrong file. Oh, it's being merciful. Okay, yeah, print the light sensor, print, and these ones have a different, whoa! Oh, I did click the wrong file. Come back. Okay, these have 2 different formats for how to read the sensor, and that's because you're addressing them in different ways. So, actually, you know what? It's pretty much the same. But one of the libraries has one format that includes underscores, and the other library has a different way of doing it. That's fine. Okay, so then, okay, let OK equals whether it's published or not. Okay, cool. And then published is OK, and message. So in this case, we're including this message string in our published feedback loop as well, our little debugging message. So you not only see it in the AWS IoT console, resume, all nicely formatted and pretty, but you also see it compressed into a single line on the console. And this is all in a JSON format, which is sort of key pair. No, that's not how you call it. How do you call it? It's like a dictionary, basically. You have corresponding values just in a list. If I got that like weird, then don't pile on me, please, because I'm not. I worked with JSON in a number of different environments, but don't have that much experience in actually knowing what it is. Okay, so yeah. Let's go on to the next tutorial. That is our publishing stuff from all the different sensors, and it gives us a lot of data, but that's fine. I'm going to pause this for a second for no particular reason. And you can control the LED strip remotely. This is where you get your feedback. So basically, so far we've done a smart button that pushes input from the board to AWS over MQTT. We've done 2 examples that read from sensors on a timer and push to AWS once per second, and how to use that Arduino to JS library, which is pretty cool. I'm kind of wondering if that's a way of just converting Arduino libraries, or if you have to find one that someone's already converted. And then now we're going to do it the other way, which is you're controlling the board from your computer, which is like the opposite, right? From AWS, in fact. Maybe I can pull this up on my phone. I wonder. I'll try that afterwards. We'll have a look. My guess is that maybe the phone is not robust enough to handle it, but maybe they have like a mobile interface for it. That'd be cool. So again, you have these 5 NeoPixel LEDs, which are WS2812s. They are RGB programmable LEDs. You use a single data pin to control as many LEDs as you want, which is really cool. Yeah, Adafruit calls them NeoPixels. You can get them in strips. You can get them in individual ones. You can get them in little, you can get them in matrices. You can get them in little like circle arrays and rings and stuff. And in this case, we just have a strip of 5 of them. They're all controlled by the same pin. And you just feed it like RGB values, red, green, and blue. And sometimes white, depending on the ones that you have. Anyway, so we're going to control this LED strip from AWS. Let's throw this into our init.js file, save and reboot. And now we're just loading MQTT and the NeoPixel library. We are subscribing to MOS topic 1. And then we have this strip that we create. 23, I assume, is the GPIO pin. Yep. So these are receiving data on pin 23. There are 5 of them, and they are in GRB format. There's actually 2 different ways that you can receive data or send data to NeoPixels. It depends on what type they are. So there's RGB ones, which receive data in red, green, blue order, and then ones that are GRB, which is green, red, blue order. And obviously, if you find out that your strip is not giving you the colors that you expected and it's like totally weird, that's probably because you have the wrong one of those. So yeah, these are in GRB format. So, this is interesting. Even though it says GRB format, down here you have strip.setPixel object pixel, which is the pixel number in the string, then R, G, and B. Oh, you know what? It probably just reformats it based on this, so you don't have to change your code. Cool! I learned a thing about NeoPixel code today. All right. Anyway, so we're subscribing to this topic this time. Remember, in the previous ones we were publishing MQTT.pub topic message 1. In this case, we are using MQTT.sub topic function. And you take these 3 parameters, which I'm going to assume is something about connection strength, or maybe just a 1 or 0, whether it's connected or not. So you're going to get this message with 3 values. Then you have the topic. Well, actually, the message includes like multiple. Oh, okay, cool. The message is a JSON string itself, and it includes 4 values: obj.pixel, .r, .g, and .v. Okay, cool. You're gonna print these to the console, the topic and the message. And yeah, then you're gonna, I did this all out of order, but hopefully you get the idea. Okay, let's just do it in order real quick. Okay, so you're subscribing to this topic, you're gonna get a message that has these attributes. It's got a connectivity value, a topic, and a message. Topic's probably gonna be topic 1. You print these to the debug console, show the topic, and then the topic, and message, and then the message. You are going to create an object that allows you to parse the values out of this message string. Then you're going to set the pixel. So strip.setPixel. I'm trying to say Sex Pistols. Anyway, so strip.setPixel is has 4 values. Oh yeah, and what it does is it doesn't actually send the values to the LEDs. You're not going to see any light until you say strip.show. And that enables you to make a few different changes happen at once, which is kind of cool. So like if you wanted every other one to be doing one thing and every other one to be doing a different thing, you can have those display simultaneously despite the fact that you set them in order. So strip.setPixel, and then you have those 4 values. And then strip.show, which actually makes the LEDs do the thing. And then you have this null value, which I'm not amazing enough at JavaScript to quite get yet. Probably has to do with MQTT itself. Anyway, so that we've just saved this and rebooted our board, and that means that it's now listening for these messages. And the next thing that we have to do is go into AWS console and give it a message to send. So let's do that. They have an example one, which is pixel 0. So that's pixel 0, which is the first one in the string there. 0, 1, 2, 3, and 4. They're not actually numbered that way. Oh, well, yeah. Anyway, in NeoPixel code, pixel 0 is the first one. It's 0 indexed. Then you have the 3 RGB values. So we've got 40 red, 120 green, and 220 blue. These values are between 0 and 256. So totally dark to full on is 256. So I'm about to. What's a good way to do this? Okay. I'm going to hit publish to topic, And there we have the first LED has turned on, and it's this sort of blue color, which makes sense because you've got almost full blue brightness, and then you've got some green, so it's got this sort of slight cyan tinge. Oh, I can't look at that. And then a little teeny bit of red in there as well, which is cool. I'm gonna see what happens if I change it to something else. I actually found that this was a little sketch yesterday. I was trying to set. Maybe I have to set them separately. Huh. Because I was trying to control multiple LEDs at once, and it wasn't working super great. So maybe I should do these separately. Well, I'm going to mess around with it in the code, and we're going to look at what the result is. Because you only have one set pixel possibility. And then it shows them all at once. So maybe I should just like set these separately. So what if I put pixel 1, and I'm going to make that, oh yeah, I'm just going to start with doing that. Publish a topic, we've got 2 of them on. Okay, so they maintain their state between commands, and that's pretty normal for NeoPixels as well. In fact, if you yank out the data line while you're still connected to power and ground, it'll just stay on its last state because it has power, but it just hasn't received any more commands yet. All right, so I'm going to be able to set these individually. So let's set pixel 2, which is the middle one, to all red, no green, and no blue. Oh no, let's make a gradient. Okay, so pixel 0 is going to be 0 red, 0 green, 255 blue. All right, that's a slightly different color. I don't know if you can see. You can tell that it's less bright, which is because you don't have that boost from the green. Okay, so now pixel 1 is going to be still 0 red with like half green and half blue. That's a kind of cyan color. The blue is pretty overpowering, so that's expected. Now we're going to do pixel 2 is 125 red. Oh wait, no, 0 red. 255 green and 0 blue. And we've got a full green pixel. Pixel 3 it's going to be 125 red. Oop, backwards. 125 green and 0 blue, and that should give us a kind of yellow color. Yep. Green plus red equals yellow in additive color. And then 4, is going to be full red, half green, or no, 0 green, and 0 blue. Cool, we made a rainbow. Great. I don't know, I kind of like it. Maybe I'll make the end one purple just because that cyan is not doing much for me. Okay, so to make that, I'm going to do 255 red and 255 blue. Maybe 125 of each, actually. Yeah. There, purple. And now I'm going to make... Wait, what? Oh, I was still editing the last one. No! Okay, let's quickly push this to the first one. Pixel 4, go back to being all red, please. And then I'm going to make the second one, which is pixel 1, be 0 red, 0 green, and 255 blue. Okay, that's pretty nice. Now we have a really great little rainbow, just in case you wanted something to brighten up your Friday. Cool. So I guess to make it possible to control all of these in one go, I would want to mess around a bit with the code, the JavaScript, and write another function that will be able to take multiple messages or something. Maybe it would be separate ones, separate messages for setting the colors and then one for showing them all, or something like that, because then you could have like set different modes or something. Anyway, there are great ways to do this. I'm not the best at programming, but this is really fun to play with, and it makes it super easy to get started with the ESP32-Pico-D4. If you don't know what that is, check out the previous video I posted today. It's got a bunch of cool links, as well as like a bunch of me talking about it and looking at those links. So go check it out. Have a great Funding Friday. We're going to be back in a minute with this hacker box. I have no idea what's in it. It's a subscription box, and we're going to talk about some Kickstarters too. All right, yeah, have a great Friday, and see you soon, and good luck getting your hands on one of these, because they're a little bit tough right now.